Hello everybody, my name is Gilles Urtubise and so for those who find my video without going through my website, let me introduce myself just like I said for my name, but my scientific and multidisciplinary scientist and inventor name is Gilles Lauzon Urtubise, and I am the owner and the founder of the first human multi-intelligence.com. So, this video is a process responsible for producing solar radiation part 3. So, like I explained partially in the same process of part 1, the sun is produce radiation with two principal set of energy. The first one is the set of the hydrogen atom, because big parts of the sun, of the surface of the sun, it's covered by only hydrogen atoms. And the second set of energy come from the other species of chemic elementary atoms, so and natural then. So yes, so and yes, like helium. So yes, about the other atoms, the composition of the sun is much lower than they said, and much lower than the scientists accept. Because for me, it's only the surface. Because all the other atoms are bigger. Their volume is bigger than the hydrogen. So, and because of this, they are all over the hydrogen atoms, and this amount of the other elementary chemical elements is it's much lower in quantity in terms of number. So because of this, all the other atoms produce small islands on the surface. So in this way, they cannot be over the other. So they are all over a nitrogen atoms. So so why the sun have iron on its surface? On the other hand, if it turns out possible and that between 136 tons and 273 tons of meteoric or meteoritic material can reach the Earth so daily. So by hypothesis, thanks to the Earth atmosphere which trap a large quantity of meteoritic material and which has no other choice but to eventually reach the surface of the ground, of the Earth. This has the consequences of representing for a year of 365 days between approximately 50,000 and 40 tons, and 100 tons and 100,000 tons and 100,040 tons per year. So this is about somewhere between 50,000 40 tons and 100,040 tons a year. So which is a lot, but it seems logic because the Earth is pretty big. So, and in the case of the Sun, which has an atmosphere, which has a temperature which is considerably higher than that of the Earth's atmosphere, but which its function differently from that of the Earth. It becomes difficult to establish the real amount of meteoritic material that can reach the surface of the Sun. When it's happened to be in the atmosphere of the Sun, but not opposite its front surface. When it's moved at a very high speed in its galactic orbit, and according to two sources which are between 217 kilometers by second and 220 kilometers by second, or which is between, in kilometers per hour, between 781,200 kilometers per hour and between 292,000 kilometers per hour. So nevertheless, the fact that the surface of the Sun it's about 11,935 times larger than that of the Earth. This has the consequences that it must receive a considerable amount of meteoric material on its front part, and also on the side of its front half, because of all the meteoric material which is drawn to the surface of the Sun thanks to the speed and the power of its surface gravity force. So an approximate potential amount of meteoric material that reaches the surface before and from the side of the front half of the Sun, that is potentially about 5,000 5,567 times greater than the quantity of approximately between 50,040 and 100,040 tons of meteoric material that reach the Earth's surface per year, which has the consequences of representing a total which is approximately between 817 millions and between 547,000.5 and 1,634,048 tons per day, or 298,613,700 tons and 596,988,497 tons per year. Sorry for my English, and I do the best as I can. So, also the age of the Sun is about 4.6 billion years. in a context where it is found to accumulate approximately between 200 this huge amount of ton by day, which is between 298,613,700 and 596,988,497 tons per day for approximately 4.6 billion years. This has the logic consequences of representing an extremely high amount of meteoric or meteoritic material, which no way days and for a period of time that is quite long. The Sun happens to have many small islands of its surface that are shaped like a single layer of atoms, and according to a global percentage for the 9 species of the largest natural chemical elements in terms of number. They are only 24.85% helium, which is only cover the surface of the Sun, which only one layers of atoms. So, but it's a large surface anyway, and the surface of the Sun, which is 0.77% with oxygen, and for the carbon it's about 0.29% of the surface of the Sun. With iron it's about a surface of 0.16% of the Sun. For neon it's 0.12%. For nitrogen it's 0.09 of the surface of the Sun. For the silicon it's 0.07% of the surface. For the magnesium is 0.05% of magnesium and 0.04% of sulfur of the surface of the Sun, and dramatically small percentage in terms of number for all the other 84 possible natural occurring chemical element species, which are on many small islands and which globally make up only 0.1% of the Sun's surface. So that's what happens. So where so now you know where those other elements come from. They come from the dust or the small asteroid or bigger asteroid. They comes in contact, in collision with the Sun or inside of his surface then. Okay, so that's good for this video. So thank you and see you to the next video.